All right. Thanks a lot, Tyler. So this session is about using service mesh in practice. So we plan to cover some of the fundamentals of service mesh and the reasons behind building service mesh solutions. And David will give an overview on Istio, and later I'll cover how Ballerina can work with and without a service mesh. So let's start with an introduction to service mesh as an architectural pattern. So first of all, why do we need a service mesh? So with the microservices and cloud-native architectures, we are segregating our services and applications into multiple services and applications. And these services and applications are connected over the network via network calls. So when it comes to realization of such architectures, building this inter-service communication is becoming one of the most complex challenges. And also, governance of these interactions. There is no central point to govern these interactions. So, governing this interaction is also becoming a key challenge. Now, in the pre-cloud native era, we used to integrate all such services, system, and data with the use of a central enterprise service bus layer. So in this particular architecture, we have a set of services and systems, and we put an ESB layer to integrate all these services, and then consumers can consume whatever the virtual services or services that we implement at the ESB layer. Now, if you look at these services, it has the business logic, which means the orchestration logic, as well as the inter-service communication technologies. So things such as resilient inter-service communication, applying observability patterns, service discovery, everything is facilitated from the ESB layer. Now, with the microservices architecture, we basically segregate ESB layer and get rid of the ESB, and we will have set of microservices doing the same thing that we used to do with the ESB. Now, in this particular use case, we have several microservices and several composite microservices, which are talking to some other microservices, and all the capabilities that are facilitated from the ESB layer are now implemented as part of your service logic. So your service will contain the business logic as well as the inter-service communication. And when it comes to microservices architecture, it always fosters a polyglot architecture, which means you will be using disparate and diverse set of programming languages to build your services. So in this use case, you have Java, Node, and Go microservices. And suppose that you want to build some inter-service resiliency as part of your first microservice, microservice X, and then you have to build it as part of your service code. And you may have to do the same thing with microservices Y. Again, you have to build it as part of your service code, but now you are using Node. So as you can see, this kind of inter-service communication, all these commodity features has to be implemented and duplicated across all these different technologies that you are using. So in a nutshell, service mesh is a solution to solve that particular problem. Now, let's have a closer look at the composition of a microservice. Now, if you look at a microservice, it has the business logic as well as the network functions or network communication logic, where you implement all the circuit breaking, service discovery, and inter-service security functionalities. So with the service mesh architecture, what we are trying to do is, so we will run a sidecar proxy along with your service, which is co-located maybe in the same pod or maybe in the same VM. So sidecar will take care of handling inter-service communication resiliency and all the non-business logic related communication, as well as it will publish network communication data to any observability tools. And your microservice code will only contain the business logic, and some primitive network functions. So why do we need primitive network functions? So as I mentioned earlier, sidecar and microservice is co-located but connected over the network. So basically your microservice is calling your sidecar over the network as a localhost call. So that's why it has some primitive network functions. All the other network capabilities, all the application level capabilities are implemented as part of the sidecar. And these sidecars are controlled via a central control plane. That is where you push all the non-business logic related inter-service communication configuration to your sidecars. So this is the high-level overview of service mesh architecture. So as part of the service mesh, there are key functionalities offered from the mesh. So obviously, resilient inter-service communication, which provides circuit breaking, retries, timeouts, etc. are provided from the mesh. And also it supports basic routing. We need to be a bit more careful when it comes to routing. You shouldn't have any business logic related routing as part of the service mesh configuration. It supports discovery, service discovery, observability, and inter-service communication. And it primarily supports synchronous messaging protocols, such as H1, H2, or gRPC. So Istio is one of the, probably the most popular service mesh implementation. So David will give an overview on Istio.
Okay, thank you very much. So first of all, based on the previous presentation, I actually saw a few hands go up with respect to people who have used Kubernetes before. So Kubernetes is pretty popular now. A lot of people are using that as a container orchestration system. How many people in here are actually familiar with Istio? Excellent, that's fantastic. How many people have actually used Istio and deployed Istio? Does anyone actually have it in production? Okay, right. So Istio is actually a pretty new program. It's open source. It was originally founded from a founding organizations, I guess, was primarily Google and IBM. From a contributing perspective now, the community's got quite a lot of momentum. There are people from VMware, Cisco, Red Hat, a bunch of other people now contributing to Istio. And it's actually gaining a lot of momentum. Istio, from a program perspective, it's still relatively new. It's at 0.8, which was released. We snuck it into the very end of May. I think it was the 31st of May. That's actually relatively, that's the current long-term supported release that's out there. It follows, Istio follows the same release cycle or the release process around introducing features in 3 different phases. They are basically alpha, beta, and then stable. When features are actually in the beta state, at that point we believe they're production ready. From a program perspective, it's been, Istio's been around for about a year, and where there is actually pre 1.0 releases going through testing right now. So it's getting pretty close to being a 1.0 open source effort. Istio really focuses, and one of the things that we were talking about just before, service mesh, microservices are awesome. The more microservices you get, the harder it becomes to maintain them, manage them, secure them. So the 3 major tenets that Istio is trying to solve is basically securing that service-to-service communication, providing a very uniformed observability across your service mesh, and also basically providing that operational agility so you can do things like canary testing, do A/B rollouts, do experimentation. So I'll actually talk a little bit about these specifically. So let's talk a little bit about the main architectural components within Istio. So Istio itself is actually the control plane. That needs to be coupled with the data plane. Lyft released Envoy, which is an open source proxy. And there's been a lot of effort around sort of using that as part of, sort of like Istio. So that effectively becomes the data plane, which is the sidecar proxy that was described in the microservices architecture. There's 3 major components within Istio from a control plane perspective. There is Istio security. There is basically Pilot, which does a lot of the configuration to the sidecar proxies. And there is Mixer, and I'll talk about that from an extensibility perspective. I am also a little conscious about the fact that we are the last presentation before lunch. So, I'm going to try and make sure we don't hold you too long.
Thank you.
So, what can you actually do with Istio security? The first thing you can do is you can secure your data path between, or your communication path between the services. So you can do mutual TLS. You can actually do authorization based on service identity. And so if you think about this, what this actually means is I can basically create access control rules. So if I have service A talking to service B talking to C and D, I can now write a policy that says A can only talk to B and it cannot talk to C and D. So things like that. You can also basically do it not just on service identity, but you can also do it on some of the attributes within the channel as well. It's not just about actually driving encryption in transit though. So one of the key things, MTLS is, it's why you actually want to do just more than the encryption on the transit side is the fact that you really want strong authentication. Right? The reason why this is really important is you need to build a very strong identity associated with those services. And if you think of, and this is pretty well known, Google runs a very flat network internally. Every service authenticates with every other service across the entire fleet. So very strong identities from a workload perspective, and it's not tied to the actual host that workload is running on. What this actually allows you to do is if you get a specific service that's compromised, you cannot replay that token to actually maybe potentially connect to another high valued service. Mixer. So one of the key attributes around Mixer is it provides a very extensible pluggable model. If I look at people who are monitoring microservice-based applications, just a quick raise of hands. Who uses Prometheus? Anyone use Prometheus? Excellent. That's pretty popular. So we actually believe that people operationally have made choices and investments in certain tools. We want to make sure that we can, from an Istio perspective, provide a very clean way to get metrics into those backends in a very seamless way. So Mixer basically provides a very pluggable model. You can actually build your own adapters if you've got something that you've done custom, or you want to plug back into some of those more well-known or well-used systems. Within the 1.0 timeframe, the Mixer adapters today are actually compiled in. There will be the ability to do an out-of-process adapter as well, which gives some additional flexibility, which means you don't necessarily have to recompile Mixer in order to actually add that in. The other thing that you'll see from Mixer is the ability to actually input policy. So maybe you actually want to create a policy around quota, those sorts of things. Mixer can be a good way to get that into your mesh. The last thing I'll talk a little bit about is Pilot. So Pilot basically pushes all your configuration to your sidecar proxies. So this is effectively doing all your network configuration, between the sidecars. It's also what you would use to potentially push your Istio access control policy from a security perspective. But it also allows, and this fundamentally, allows for things like, I can now control traffic. I could do things like, again, A/B rollouts. I can actually break specific percentages of my traffic from one version of service to a second version of service without actually having to change my network. So I think, at a high level, that's kind of what Istio's looking to solve. Again, if there's a stack of information on istio.io. There's even some pretty interesting tutorials and stuff there as well. And I'll be around during both lunch and the break and the breaks. Please, if you've got any questions at all, please don't hesitate to reach out. I'm actually going to now hand you back, and so we can talk a little bit about how Istio and Balerina work together.
Yeah. Thanks, David. So let's have a look at the relationship between Ballerina and Istio, how you can use Balerina with and without Istio. So using Ballerina with Istio. So this is a pretty straightforward use case. So this would be very similar to using any other programming language with Ballerina. So in this case, Ballerina will have the business logic, and all the network and non-business logic related capabilities are provided from the mesh. And However, unlike other programming languages, owing to the unique cloud-native features offered from Ballerina, the integration between Ballerina and Istio is seamless. So, these are some of the key steps that you can follow when building a Ballerina service that can be directly deployed into Istio. So basically, as Lakmal showed in his presentation, you can create a Ballerina service, annotate that with Kubernetes deployment and service annotation, and then you build the Ballerina service. So it will generate a single YAML file with all the deployment and service descriptors for Kubernetes. And if you are using Istio manual sidecar injection, you have to manually inject the sidecar into your Kubernetes artifacts. Or if you are not using manual sidecar, or if you are using automatic sidecar injection, you can directly deploy the Kubernetes artifacts. So once you manually inject the sidecar, then you can directly deploy that into Kubernetes. So that's all you have to do. And also, if you want to include any Istio-specific artifacts such as virtual services or gateways, then you need to manually incorporate that into the generated YAML file. So we are also exploring on whether we need any first-class support for Istio when it comes to this kind of deployment. So that's ongoing work. And so how about running Ballerina without a service mesh? So probably you may have noticed that we have a lot of overlapping, a lot of common features between Ballerina and Istio when it comes to inter-service communication. So for example, things such as resilient communication, observability, security, multi-protocol support, and service discovery. So all those things are also supported in Ballerina. So when to use Ballerina without a service mesh? So obviously the first use case is you are not using a service mesh, right? So in that case, Ballerina would be one of the best choices because it provides all these network and inter-service communication capabilities as part of the language. So you don't have to fetch any external libraries such as Hystrix to build them. And also when it comes to asynchronous event-driven messaging, service mesh architecture is predominantly works for synchronous messaging at the moment. So there are some ongoing work related to Envoy on supporting asynchronous messaging protocols such as Kafka, but currently it only offers first-class support for synchronous messaging. So therefore, if you have use cases which contains asynchronous messaging, then Ballerina will be a great choice, and you can use Ballerina without Istio, without service mesh in that use case. And also there are certain use cases where you have you cannot really decouple your business logic and network communication logic. For example, the transactions that Asit showed you, as well as in some cases retries can be, things such as retries can be also part of your business logic. So in that case, you can build such business logic dependent inter-service communication as part of your service code. All right, so to give a quick summary on what we have discussed so far, so we discussed about what a service mesh is, and David gave you an overview on Istio. And so as some guidelines, we can conclude that Ballerina can work with Istio and without Istio. And it's always good to have a clear separation between your inter-service communication logic and your business logic. So the inter-service communication can be implemented as part of the service mesh, whereas Ballerina can be used to implement the business logic when you are using Ballerina alongside a service mesh. Okay, thank you very much.
So just before we wrap up, is there any specific questions at all? If there's any questions, please don't hesitate to reach out. Yep.
Service mesh inject the service mesh manually or directly. So how Balerina is helping with that perspective? That's not what we see here.
So your question is on Ballerina also provides this net.
So how Balerina is overlapping, what portion of the work Balerina is overlapping with Istio?
Yes.
It looks to be like two different silos. One is business,
Yeah.
process-wise, business
Yeah.
Balerina is doing,
Yeah.
creating microservices, and also maybe creating the artifacts for the Kubernetes point of view.
Yeah.
But the service mesh comes on a whole different level, like where it is doing other, like helping to manage the Kubernetes artifacts. So how so the connect, and you mentioned that there's some overlapping between
Yeah.
Balerina and Istio.
Yeah, so overlapping features are mainly network communication related features. I'll give several examples. Circuit breaker, retries, timeouts, all are part of Istio as well as Ballerina. Service discovery, observability. For example, if you write a Ballerina service and just put a configuration file to connect with any observability tools, you can get seamless observability for your service. So I would say all the network related communication capabilities, there are common set of features. So based on your use case, you can either leverage them from Ballerina, or if you are on a service mesh environment, you can get them directly from service mesh. And other aspect is, usually when you are running a real world microservices architecture, you may have Ballerina services as well as other services like Spring Boot or any other service. So in such scenarios, having service mesh will be helpful, because in other programming languages, you don't get these features built into those frameworks and languages.
And I'll just add one more thing to that. So if you think of, in the very first slide where we talked about microservices architecture, one of the key advantages of that is the fact that I can, write my front end in Node.js. I could write the back end maybe in Go or Java or something like that, right? And if you implement a lot of the networking type capabilities across different versions of different coding languages, you tend to get nuances in both compatibility and how they behave and what metrics and stuff you get out of them, right? And that's actually one of the benefits of something like Istio or a service mesh, is it just gives you that consistent, networking and metrics information across, irrespective of what actual language you're writing your code in for your business logic. Does that help answer your question? Okay. Any other questions at all? Yes?
So I couldn't really catch the question. So you have some services in-house, is it? And you need to wrap them with...
For example, I need to write the code and I need to use some services. I don't want to describe that inside the code. I would like to go to the repository and take some description and use it. I don't know if it's connected to the service
Hey, are you
but
Yeah. So as far as I understand, you have some set of services and in a kind of a registry, and Ballerina have to, whatever the language has to go and discover the service, and also, so if you just want to discover the service endpoints, it's already been implemented as part of service mesh, and as well as Ballerina can connect to any registry implementations such as console. So basically what you are giving as part of the service code is just a reference to your service, URL just as a key, and it will automatically discover it from the underlying registry environment. Yeah, maybe. Yes, thanks.
Right, so I think at this point we probably want to, I think everyone wants to go to lunch. So if there's any more questions, please feel free to meet us outside. and we can continue the conversations at any point in time. Again, my name's David Munro. Happy to help out in any way I can.
Thank you, David. Kasun.